Power amplifier. A practical amplifier consists of many stages such as microphone, voltage amplifiers, power amplifier, and speaker. In most of the practical amplifiers, the output stage is power amplifier. A power amplifier uses power transistor. A power transistor, it is large in size in order to handle large powers. The collector region of the transistor is made large and a heat sink is placed at the collector base junction in order to minimize heat generated. The emitter and base region of a power transistor are heavily doped. Due to the low input resistance, it requires low input power. Power amplifiers are mainly classified into two, such as small signal amplifier and large signal amplifier. Small signal amplifiers handle small input AC signals, a few microvolt or millivolts. Large signal amplifiers handle large input AC signal such as a few volt. There are more classifications such as audio amplifiers, radio frequency amplifiers, narrowband amplifiers, and wideband amplifiers. In any practical system, we have a voltage amplifier and a power amplifier. Let us compare voltage and power amplifier. A voltage amplifier has a voltage gain AV is equal to beta RC by Rin. The transistor with a high beta is used in a voltage amplifier. The input resistance is low when compared to collector load RC. The collector load should be relatively high. To permit high collector loads, the voltage amplifiers are always operated at low collector current. In power amplifiers, the base of transistor is made thicker to handle large currents, that is smaller beta values. Thus, in a power amplifier, the base is thicker, but in voltage amplifier, the base is thin. The size of power transistor is considerably large. Transformer coupling is used for impedance matching. Collector resistance is made low. Let us conclude. Beta for voltage amplifier is high and for power amplifier it is low. RC is high and low in power amplifier. Normally in voltage amplifier coupling is RC coupling and in power amplifier it is transformer coupling. Input voltage is low in voltage amplifier and high in power amplifier. Collector current is low and high in power amplifier. Output impedance is high in voltage amplifier and low in power amplifier. For a power amplifier, there is some performance quantities such as collector efficiency. It is the ratio of AC output power to the zero signal power, that is DC power, supplied by the battery of the power amplifier. That is, eta is equal to AC power output divided by DC power input is equal to PO by PDC. PDC is VCC into IC and PO is VCE into IC, where VCE and IC are RMS values. We can calculate the RMS values by using RMS value is equal to half into peak to peak value by square root of 2. In peak to peak values, we have PO is equal to VCE peak to peak by 2 root 2 into IC peak to peak by 2 root 2. That is, PO is equal to VCE peak to peak into IC peak to peak by 8. 2 root 2 into 2 root 2 is 8. Eta is equal to VCE peak to peak IC peak to peak divided by 8 into VCC into IC. Distortion is the change of output wave shape from the input wave shape of an amplifier. Power dissipation capability is the ability of a power transistor to dissipate heat developed in it. Power amplifiers are classified such as Class A power amplifier, Class B power amplifier, and Class C power amplifier. There are further classifications like Class AB power amplifier, Class D power amplifier, Class E power amplifier, etc. Class A power amplifier. In a Class A power amplifier, the collector current flows at all times during the full cycle of the signal. This is a Class A power amplifier. Here we use one transistor in common emitter mode and its graphical representation is this one. This is the input signal and output signal is this one. The Q point is at the center of the load line. The operating point Q lies at the center of the load line. The power amplifier is biased such that no part of the signal is cut off. The output waveform is same as the input waveform. That means we use 360 degree. Since the output waveform and input waveform are similar, there is least distortion. The maximum power dissipation in the transistor occurs under zero signal condition. Class A power amplifier have low power output and low collector efficiency. Series fed Class A power amplifier. This is circuit diagram of a series fed Class A power amplifier, and this is a graphical representation. We can calculate maximum collector efficiency. Maximum VCE peak to peak is VCC. Maximum IC peak to peak is VCC by RC. Maximum AC output power PO max is equal to VCE peak to peak into IC peak to peak by 8. That is equal to VCC into VCC by RC by 8. That is equal to VCC square by 8 RC. DC power supplied PDC is equal to VCC into IC. That is equal to VCC into IC is half VCC by RC. That is equal to VCC square by 2 RC. The maximum collector efficiency eta is equal to PO max divided by PDC into 100. That is equal to 25%. Thus, in a series fed Class A power amplifier, have a maximum collector efficiency of 25%. Transformer coupled Class A power amplifier. This is the transformer coupled Class A power amplifier and the graphical representation. Here transformer coupled is using at the collector of the transistor. Maximum collector efficiency can be calculated as maximum VCE peak to peak is 2 times VCC. Maximum IC peak to peak is 2 IC. That's equal to VCE peak to peak divided by RL prime. That is equal to 2 VCC by RL prime, where RL prime is the reflected value of load RL and appears in the primary of the transformer. We can calculate N such that N is equal to NP by NS is the turn ratio of the transformer. Then RL prime is equal to N square RL. DC power input PDC is equal to VCC into IC. That is IC square RL prime, since VCC is equal to IC RL prime. Maximum AC output power PO max is equal to VCE peak to peak into IC peak to peak by 8. That is equal to VCC into 2 IC by 8. That is equal to half VCC IC. That is equal to half IC square RL prime. Maximum collector efficiency eta is equal to PO max divided by PDC into 100. On calculating, we have 50%. Thus, in a transformer coupled Class A power amplifier, have a maximum collector efficiency of 50%. Class B power amplifier. In Class B power amplifier, the collector current flows only during the positive half cycle of the input signal. This is a Class B power amplifier. Here we use 2 transistors. The Q point is here and only positive half cycle is used in the output signal. The operating point Q lies at the collector cutoff voltage. The power amplifier is biased such that negative part of the signal is cut off. The input circuit is forward biased during positive half cycle of input signal, whereas it is reverse biased during negative half cycle. As the negative half cycle is cut off, severe distortion occurs in Class B power amplifier. High power output and high collector efficiency is there in Class B power amplifier. Class B power amplifiers used in push-pull arrangement, in which one amplifier operates in positive half cycle and other amplifier operates in negative half cycle. Class B push-pull amplifier. Push-pull means one transistor conducts for half a cycle while the other is off and vice versa. This is a push-pull Class B power amplifier. Here, for the positive half cycle, base of transistor T1 becomes positive and collector current flows. At the same time, the transistor T2 has negative half cycle, which throws transistor T2 into cutoff condition and hence no collector current flows. In the next half cycle, transistor T1 is cut off and transistor T2 conducts collector current. Complementary symmetry push-pull Class B amplifier. One transistor is NPN, other is PNP. During the positive half cycle of the input signal, the NPN transistor T1 conducts and PNP transistor cut off. T1 conducts, T2 cutoff. During the negative half cycle, the NPN transistor cutoff and the PNP transistor conducts. In this way, the NPN transistor amplifies during positive half cycle of the input, while PNP transistor amplifies during negative half cycle of the input. Class C power amplifier. In Class C power amplifier, the collector current flows for less than half cycle of the input signal. This is a Class C power amplifier. In this graphical representation, the output is less than 180 degree. The negative bias is given to the base of the transistor. Therefore, collector current does not flow when the positive half cycle of the signal starts. The Class C amplifiers are never used for power amplification as they amplify narrow band of frequency near the resonant frequency of the LC circuit. They are used as tuned amplifiers. The maximum collector efficiency of Class C power amplifier is approximately 100%. For Class C amplifier, it conducts 360 degree. Distortion is small due to nonlinear distortion. Maximum efficiency is 25% and you can increase to 50% by using transformer coupling. Class A amplifier is used in low power amplifiers where efficiency is not important. Class B power amplifier conducts 180 degree and small to moderate distortion due to crossover distortion. Maximum efficiency is 78.5%. It is used in audio power amplifiers. Class C power amplifier conducts less than 180 degree and it have large distortion. Maximum efficiency is approximately 100%. It is used in tuned RF power amplifiers and in final amplifier stage in communication circuits.